So we did a little bit with greatest common factor, didn't we? Let's see. It's been a while since we've been in here, so let's put those numbers down. I think these are the same numbers that we did in class, but I'm going to do them again. I'm going to do them a little bit faster this time. Okay, so what if they give you three numbers? And the first problem's in the homework section of this. This is what they do. They give you a handful of these numbers, and you have to find the greatest common factor. So we're going to do it with all three of these numbers. So I use a thing called a factor tree. So you can go. So let's break this down. So I'm just going to do it the way I would do it. Okay, I'm looking at this. I'm going 6 times 10. I'm breaking this down. Break it down into its prime factors. Remember we talked about prime numbers last time we had class? So this is 2 and 3. And then you break this down, and this is 2 times 5. All right? So what are your common factor, or what is your, we're not even finding the greatest common factor just yet. Let's put it in order. Let's go 2, 2, 3, 5. Okay, so we'll keep that there for a second. What we're going to do is find the greatest common factor between these three numbers, all right? But we're going to break them down into its primes first. Okay, 84. So when I think of 84, I don't know, like 4 goes into it, right? I know that. 4 goes into it, what, 21 times? All right, so we'll break that down. 21 is what, 3 times 7? 4 is 2 times 2. Let's put it in order. It's just a little bit easier to work with. You don't absolutely have to do that, but it is a little easier to work with. All right, so I've got this, and I've got this. Everybody following? It's pretty easy. Especially when it ends in a 0, what do I always do? 18 times 10. Yeah, that's the easiest thing to do, I think. And break down 18. What's 18? 2 times 9, right? Break down, or you can go 6 times 3. All right, break down 10. Yep, 5 times 2 or 2 times 5, doesn't matter. I'll put dots in there for the multiplication. Break down 9, so I got what? 2 times 3 times 3, right? And then you bring that down, that's 2, and that's a 5. Put them in order, 2, 2, 3, 3, 5. All right, so I broke them down into their prime factors. Now what I want to do is find the greatest common factor. What does that mean? That means I want to find the largest number that is in common with all three of those numbers. Okay, what's the biggest number that's in common with everything right here? So what I'm going to do is look to the factors. Look what I had. I got 2's here, I got 2's here, and I got 2's here. How many 2's show up? 2 of them, right? I got 2 of them here, 2 of them here, and 2 of them here. If they show up the same number of times in all three places, then I just pick one of those pairs of numbers, all right? So 2 shows up here twice. I'm just going to pick 2 of them. Okay, I'm going to circle them. What else shows up? A 3. So there's 1 3 here, 1 3 here, but 2 3's here. But I want to find out how many are actually in common with all three of them. Are there 2 3's in all three places? No, there's only what? There's only 1 3 in all three places. You follow me? There's 1 here, there's 1 here, there's 1 here, there's 2 here, but in common, what do they have in common? They just have 1 3 in common. Yes? Because there's not 2 here and there's not 2 3's here. So they only have 1 3 in common, so I pick one of them. I could have picked this one, I could have picked one of these. I just picked this one. Let's go through the 5's. I got a 5 here, don't have a 5 here, but I have a 5 here. So do I have a 5 in common with all three of them? No, I don't. So I don't circle any 5's. They have to be in common with all three. Everybody got this? Got like 3 people actually watching me, but that's all right. I'll teach the 3 people. What else do we have? I got a 7, but I don't have one here. Don't have one here, but I got one here, but I don't choose it. Okay, I don't circle it because it's not in common with all three. It has to be in common with all three of them. 7 is not in common. So what's in common then? I got a 2, and a 3. Multiply those together. 4 times 3 is 12. That right there is my greatest common factor. What does that mean? What does that do for us? That means the number 60, the number 84, the number 180, what is the largest number that is in common that can easily, or that can be evenly divided into all of these numbers? What number? Well, there's a 2, right? But is that my largest common factor? No. 4 goes into all 4 of those, but is that my largest one? No. What's my largest number that divides evenly into all three of these? It's 12. That's what we're finding. We're finding a number that divides evenly into all three of the numbers that they give us. Does that make sense? All right. So what we're going to do now is we're going to use this. All right. Again, that's all the ones like this we're going to do. They do give you some in the homework. They give you like, I don't know, 4 maybe 5 problems where you have to find the greatest common factor, and that's what you do. All right. You go through here, see what's in common. If there's one in common, if there's like 2 2s right here and 2 2s here, 2 2s here, then I take the one that shows up the most number of times. For instance, like the 3s. I got 1 here, 2 here, all right? But I don't pick 2 of the 3s because I only have 1 here and 1 here. What if I had this? This has nothing to do with that number. I'm just making this up. What if I had, like, I don't know, 2 times 2 times 3 times, yeah. Then I had another number. Let's say I had 2, 3, 3, 5, and then let's say I have another one. So I've got 2, 2, 2, 3. I'm kind of doing the same thing. I'm not picking numbers that are good. All right, but let's say, what do? You look at the 2s. I got 2 here, I got 1 here, I got 3 here. So which one do I pick? The 1, because that's the only one that's in common with all 3 of them. Let's do the 3s. I got 1 3 here, I got 2 here, I got 3 here. Which one is in common with all 3 of them? Just the 1, okay? Is there anything else in common with all 3? There's a 5 here, but it's not here and here. And that's it. So what's your greatest common factor then? It's just 6. It's greatest common factor. So that's kind of what you're doing. Everybody got that? All right. So that's how to do that. All right. Now what we're going to do, if you looked at the title of this, we're not just factoring, we're factoring out. There's a difference. We're factoring something out. All right. So let's do a quick little review before we actually do the factoring. So this is stuff that we've done before, but I'm doing this for a reason. Alex. It doesn't matter. You know what it means, okay? So it doesn't matter what it looks like. My handwriting is not always the best, but you know what those words mean, so it doesn't matter what they look like. So here we go. What if I gave you something like this? This was basically the last stuff that we did. All right, it's distributive property. And let's do that. Let's actually do distributive property and see what this is. But I don't know if you remember, but the last time we talked, we were going to take the answer, we're going to go back to the question, and that's what we're going to do today. So, but let's do a little review right now. All right, so let's distribute this right here. So what do I have? 2 times 3, 6, x cubed times x squared, x to the 5th, and then y cubed. Not explaining why. We've already explained that in the past. You should know how to do it. Minus 2 times 4, that's 8. Then I got x cubed. And I got y to the what? 6, because you add the exponents. Okay, so now what I'm going to do is this. I want to go from this, from the answer, back to the question. Okay? That's what I'm doing. All right? And we do that. This right here, it just says multiply or distribute. This right here, we're going to tell you to factor. All right? So when it says to factor, this is what we're doing. We're basically starting with that. And I want to find out what times what equals this thing here. Hear what I just said? Okay, so the question is, when it says to factor this, I want to find out what times what is equal to this thing right here. Well, you know your answer. It's that. Okay, but how did we get that? Well, first of all, we do the factor thing that we just did before. I got a 6 and an 8. Let's write that down. I got a 6 and I got an 8. At some point, you should probably be able to do this in your head, but if not, this is where you would go. So break down 6. What times what is 6? Yep, 2 times 3. I'll start with the lowest one first. What about 8? It's 4 times 2, or if you break it all the way down, can you do that in your head? 2 times 2 times 2. Agreed? All right. So what do? I look to see which numbers show up in both places. I got 1, 2 here, and I got 3 here. Which one am I going to pick, though? Okay, I'm only going to pick the 1, 2, right? That sounds weird, but the O-N-E, number 2, okay? So I picked the 2. This has a 3. Do I pick the 3? No, because I don't have a 3 here, okay? So that's the only thing that's in common, isn't it? Would you agree? With 6 and 8? Yeah. So that's what I'm going to pick. So for 6 and 8, I'm going to find my common factor, which is a 2. Let's do the same thing with the x's. What if I had x to the 5th and x to the 3rd? Because that's what I have in both of these, right? Let's find out what's in common with these two. Now, I'm only going to do this the one time, all right, just to show you. What is x to the 5th? It's x 5 times, right? 1, 2, 3, 4, 5. How many x's here? So how many are in common with both of these? Just 3 x's are in common with both. Yes? All right. So what's my greatest common factor with x to the 5th and x cubed? It's x cubed, isn't it? So that's my greatest common factor. So what I'm doing is I'm factoring out, right? That's the name of this lesson, factoring out the greatest common factor. What about the y's without doing any of this stuff? Because you don't really need this stuff after you get the hang of this. I got y cubed, I got y to the 6th. What's in common with both of those? Y to the 3rd, y cubed, that's right. So y cubed. So what I'm doing is I'm factoring it out. Okay, so what I'm going to do is put a parentheses there and find out what's going to be left inside the parentheses. Well, look, what did we do to get 6x to the 5th y cubed? What did I do to those two things to get this? I multiplied, right? So, guess what? What am I going to do with this and this? I went from here to here to multiply, but if I go backwards, what am I going to do? I'm going to divide. I'm going to divide. All right, that's the key. So when you factor something out, you're dividing it out. Okay, I got to keep that there. Just got to see the number. So I'm factoring it, I'm dividing it out from this. So basically, I'm going to write this down, but eventually you shouldn't have to write this down. You should be able to look at it and kind of do it in your head, okay? But right now I'm going to write it down. And let's put it in another color just so that this is kind of off to the side stuff. So what I'm going to do is take that 6x to the 5th y cubed, and what am I dividing it by? The 2x cubed y cubed, my greatest common factor. So I take the first term right here, and I divide it by the 2x cubed y cubed. Okay? So 2x cubed y cubed. And again, eventually, once you get used to this, you shouldn't have to write it down. If you want to, perfectly fine. But let's do the division now. Let me grab that. Okay. So what do I have? How do I divide that? Well, 6 divided by 2. What's 6 divided by 2? 6 divided by 2 is 3. Okay. What's x to the 5th divided by this x cubed? What's the rule for division? Right, you subtract the exponents. That's right. So this would be x to the what? Seconds, x squared. What's the y's? What happens with the y's? Cancel out, right. Y to the 3rd over y to the 3rd is just 1. 1 times that is that. You with me so far? So I'm going backwards, okay? This is backwards distributive property. So I'm not multiplying. What am I doing? Dividing. All right, let's do the same thing on this one. Don't write it down this time. Let's look up here and look here, and let's do it in our head. So I've got 8 divided by 2. What's 8 divided by 2? 4. And I got x cubed divided by x cubed. What's that? Yeah, it's a 1, right? It's a 1, and 1 times 4 is just 4. I got y to the 6th divided by y cubed. What is that? Y cubed. That's right. How did I get y cubed? I do what to the exponents? Subtract them. 6 minus 3 is 3. That's my answer right there. That is factored. And let's take a look. Does that look like that? Absolutely. Do you see what we did?
Good afternoon, faculty and students. If anyone has seen a purple Stanley cup, please report it to the main office. Thank you.
Okay, so look, we went from here to here by multiplying, but then I went from the answer back to the problem by doing what? factoring something out and then dividing. All right, that's what factoring is. I want to find two things that multiply together to become this. That's what we're doing. I spent a lot of time explaining that. Let's do another one. Let's do a little faster though, okay? You did this in Algebra 2, didn't you? You said no, you didn't do this in Algebra 2? You sure? Or were you just asleep when you went over it? You didn't do any factoring in Algebra 2, not Algebra 1. I mean, you should have done this in Algebra. Did you do it in Algebra 1? You should have done this in Algebra 1, to tell you the truth. Yeah. This is technically an Algebra 1 topic. I mean, if I was to teach an Algebra 1 class, I'm sure that at some point I would be teaching this. All right, here we go. Example 3. Let's start from scratch. I'm not going to do that review thing. We're just going to start with a binomial, and I'm going to factor it out. All right, so here we go. It says to factor 25a cubed b plus 15ab cubed. All right, so where do we start? I'm not doing any dividing just yet. I have to find the what first? What have we been talking about the whole day? Greatest common factor, the GCF, greatest common factor, okay? So I look at 25 and I look at 15. This is a number that you probably can do in your head, all right? What number divides evenly? What's the biggest number that divides evenly into 25 and 15? 5 does, okay? Is there anything bigger? No, because this is 3 times 5. This is 5 times 5, right? Okay, what's the only thing they have in common? Just 1 5. If you needed to do it off to the side, feel free to begin doing it that way. But I said begin doing it that way. Don't continue to do it that way. You should be able to look at that and say, oh yeah, my greatest common factor is 5. What about the a's? I got an a cubed and an a. What's in common with both of those? One what? 1a, just an a to the first, or a. Everybody see that? All right, because there's an a cubed here. Does this one have an a cubed? No. So it doesn't have an a cubed in common. It only has a single a in common. Agreed? All right, do the b's. Is b the first? If you didn't realize that, you should have. B the first, b cubed. What do they have in common? Not a 1. Don't say 1. A b. They have a b in common. 1b. You could say 1b, but don't say 1. Everything has 1 in common. Would you agree? Everything has 1 in common. So now, what do? I got my greatest common factor right here. I put a parentheses. Now remember, I'm doing backwards distributive property, right? So I want to go this times this is that. This times this is that. But how do I figure out what's going to go in this spot right here? What's my math? What do I do? Do I add, subtract, multiply, divide? What do I do? I divide. That's right. You got it. 25 divided by 5 is 5. A cubed divided by a to the first is what? A to the second. Right, a squared. Okay, because 3 minus 1. All right, I got b over b. B divided by b is just a 1, cancels out. And I like to think of it becomes a 1. Okay, 1 times this is just 5a squared. All right, so that's it for that. Let's do it for this one. Now I'm going to take this greatest common factor, and I'm going to take this divided by that greatest common factor. So 15 divided by 5 is 3. A divided by a is, now don't say cancel out. What do I say? What's a divided by a? Give me a number. It's 1. It's the number 1. 1 times 3 is 3. B cubed divided by b is b squared, b to the second. That's it right there. That's factored. It's as easy as that. It's really not that hard, is it? No. If you wanted to check, you could always distribute, right? And it should equal what we started with. If it doesn't, you did something wrong somewhere. You either checked it wrong or you did the problem wrong, okay? That's why I never understood the teacher saying, well, check your answers. Make sure you check your answers. Well, yeah, well, what if I mess up checking? I could mess up checking, couldn't I? So I don't know. I don't know if I messed up actually checking it or if I got the problem wrong to begin with. But I think it is still a good idea because if you do both things right, you should come out to the same thing. So let's just check it. 5 times 5 is 25. A times a squared is a cubed and then b. Is that what we have here? Absolutely. Plus, let's do this. 5 times 3 is 15. A, b, what? Cubed. Is that what we had to begin with? Absolutely. So it does check, all right? But this technically is my answer right there. That's how you factor. All right, let's do another one. And then we'll stop. Nope, 2 more. I got 5 minutes. I got time. So example 4 says to factor again. Some books say factor completely. This book, I think, just says factor. So here it is. 3xy squared z cubed plus. Now you know this is going to be a little bit more involved than the first ones, right? Z cubed minus 3x z squared. Let me make sure I wrote it down right. Yep, that looks good. Okay, so here we go. First thing we do is what? Find the, yes, say the whole thing. Greatest common factor. Greatest common factor, okay? This should be easy. I got a 3, got a 6, got a 3. What's in common with a 3 and a 6 and a 3? Just 3, and that's the biggest number, right? I don't put 6 because 6 is not in here and it's not in here. What's in all 3 of them? There's a 3 in all 3 of them, yes? All right, so that's our greatest common factor. 3. The x's, I got an x, I got an x, I got an x. What's in common with all of them? Just one x, x of the first, or just x. Do the y's. Y squared, y, no y's here. So is there y's in common? So it's not going to be in my greatest common factor. Do the z's. Z cubed, z squared, which one? Z squared is in all 3 of them. So basically you're just taking the smallest one, right? Even though it's technically the greatest common factor. That could get confusing. But I just like to look at it as what's in common with all 3 of them. Okay, so that's my greatest common factor. Let's figure out what we do now. I got to take this and do what? Divide it by this. So let's do it one at a time. 3 divided by 3, 1. X divided by x, 1. I don't have anything to divide that by, so I just write down what? Y squared. And then z cubed divided by z squared. What's that? Is just z. And I'm good to go on the first one. Now I do the same thing for the other 2. Okay, put a plus, since there's a plus there, 6. 6 divided by 3, 2. X divided by x, 1. There's no y here, so y divided by 1 is just y. And then z cubed divided by z squared is just z, just like we did before. You could put the 1 there if you wanted to. You don't need to. Now watch this. Be very careful on this one. The whole reason I said x divided by x is what? 1 is because of what I'm going to do here. Watch. 3 divided by 3 is 1. X divided by x is 1. Z squared divided by z squared is 1. What's 1 times 1 times 1? It's 1. So you have to put a 1 there. You cannot think of it as they just cancel each other out, all right, and they go away. I mean, technically they do cancel, but what do they cancel to be? They cancel to be a 1, all right? It's super important that you see that. That's it. That's your answer right there. You are done. If you wanted to check it, you could. You could do distributive property, see if it works. Feel free. Let's do one more and we'll quit. Example 5. So I've got 3x squared plus 4y plus 7. And what do they say to do to this? Factor. All these say to factor. All right, let's find a greatest common factor. I got a 3, a 4, and a 7. Is there anything in common with 3, 4, and 7? Yeah, 1, but 1's in common with what? Everything. So, is there? No, there's nothing in common except a 1. All right? What about the x's? I got an x squared here. I don't have an x here, and I don't have an x here. There's nothing in common. What about y's? Is there anything in common with this? Can I factor it? There is nothing that multiplies together to become this. All right? So you can't do anything. You would just circle this, and that would be my answer. It's not even... No, don't even do that. Don't even do that. I'm sorry. Just say it cannot be factored. Cannot be factored. Okay? That would be your answer right there. Because if I circle that, that's really not a factor. You could just say 1 times that, but again, you could factor out 1 to anything. So you're good there. Does that make sense? So now, if somebody says, did you learn how to factor stuff? You cannot say, no, we never learned that. All right? So, but I have a feeling that you probably did learn it. My guess is that you did. You just don't remember. I would hope so. I would hope, at least in Algebra 2, that you learn how to do some basic factoring. Because that seems to me like it's been a lot of years since I've taught Algebra 2. My goodness, it's probably been close to 20 years since I've taught Algebra 2. And I used to teach Algebra 2 every year. That was my favorite class to teach. Did I ever tell you why I don't teach Algebra 2 now? So we had a teacher here. I won't say her name since I'm still recording. We had a teacher here, and she taught in the other room. And she is now the department head at Wilmington University, the math department head, the main person. She's got her doctorate in math now and all this stuff. But she would come to me, and she would be upset sometimes because she couldn't control the kids, and she didn't know the right way to teach this, and the kids weren't learning, and man, she would come in tears and everything. Now she's a doctor in math, and she's over there. But anyway, she wanted to teach her daughter. Her daughter was going to be in Algebra 2. She wanted to teach her daughter the next year Algebra 2. So she says, Aaron, just for 1 year, could I teach the Algebra 2 class? I was like, oh, I love that class. It's my favorite class. But I let her teach it, and that was a long, long time ago. And I haven't taught it since. So this is about the closest I come to teaching Algebra 2 is my college algebra class. So anyway, not the most exciting story in the world, but that's my Algebra 2 story.